We can make a picture of an atom as simple or as complicated as we like. We can show a hydrogen atom as the central nucleus or proton, circled by a single electron. The proton has a positive charge and is 1840 times the mass of the electrons, which has a negative charge. The electron circles the nucleus millions of times in a millionth of a second, and hundreds of millions of atoms side by side would be needed to occupy an inch of space. Positive and negative charges, protons and electrons, neutralize each other, so the atom has no surplus charge. Helium has 2 electrons and 2 protons. The heavier the element have more and more electrons. Uranium has 92 electrons, but normally has no surplus charge because the negative electrons are balanced by the positive charge of the nucleus. There are other particles besides protons and electrons. The neutron has no charge and is found in some atoms. Other transitory particles arise, change their state, or apparently disappear in energy. A hydrogen atom can absorb a proton or light particle and take energy from it, moving to an orbit at a higher energy level, or electrons may collapse to a lower energy level, emitting photons. We have seen that normally the negative electron charge equals the positive nucleus charge. The atom has no surplus charge. However, sometimes an atom may gain an electron and then has a surplus negative charge. If an atom loses an electron, the nucleus protons are more numerous than the negative electrons, so the atom has a surplus positive charge. With semiconductors, we may speak of positive holes or hole carriers. This can be imagined as spaces which could be occupied by negative electrons. A body with a considerable excess of electrons has a strong negative charge. One with fewer electrons has a strong positive charge. Thus, there is a difference of potential which exists so long as there is no means of electrons escaping or nuclei gaining the electrons they lack. If something allows a free movement of electrons between the negative and positive charges, electrons moving through the conductive path to occupy the nucleus which lacks electrons. This movement is an electric current and can take place through any conductor such as a wire. We should be aware that we have portrayed the atom as being a linear logical substance, but far from it in reality. Their orbits are constantly changing due to the influence of other subatomic particles. If the movement of electrons are to be maintained, we must generate or produce a continuous surplus, which replaces the electrons travelling away from the conductor. In equipment, current can flow from the battery negative to the lamp or other apparatus, then back along a second conductor to the battery positive. Conducting leads, etc. form the circuit. The surplus electrons at one terminal of the circuit can be produced and can be maintained chemically by a battery. This is very handy for portable equipment, or it may be produced electromagnetically by a generator. Again, photoelectric cells produce current under the stimulus of photons or light particles, whilst a thermocouple or junction of different metal produce current when the temperature is raised.